Hey everyone, welcome to this week's Cribl Weekly demo, Managing Large Lookup Tables with Redis. Before we jump in, just wanted to take the time to introduce myself to those of you that I haven't met. I'm Desi Gavis-Hewson, and I'm the Senior Solutions Marketing Manager here at Cribl. Prior to being at Cribl, I led the National Sales Development team at a co-working company called Industrious. Before that, I was on the sales team at an ad sales enablement company called Media Radar, and I helped build the sales development team at Trello. So my path here to Cribl is a little non-traditional for sure, and I've been in a few different industries in my career. Ultimately, though, it was really a no-brainer for me to come here because I really enjoy matching people and teams with tools that give them more flexibility and choice in their business. Ultimately, that's what our flagship product, Cribl LogStream, provides. So great to meet you. Here's what to expect on today's call. Let's get into it. So almost every week, we'll be doing a demo of Cribl LogStream and walking through specific use cases within the product. So first, I will do a quick intro to observability pipelines and LogStream for those of you who may not be as familiar with us or what we do. From there, we'll move into a full demo of LogStream. We'll talk through the specific use case for that week. Obviously, this week, that's going to be managing large lookup tables with Redis. Then you'll have the opportunity to ask some questions of me regarding Cribl LogStream, the Redis function, or anything you've heard or seen here today. So global data is growing at a 25% compounded annual growth rate. And I think everyone in the world understands this to a degree. If you take being in a global pandemic, for example, rather than our business meetings happening in person, they're happening on Zoom. And Zoom's generating data. So even if you think about it from a non-technical perspective, it's really easy to see that data is growing astronomically. By 2025, enterprises will be managing 250% more data than they were in 2020. So the amount is growing, but there is another problem. Logging systems are already at capacity. I talk to enterprises every day with costs in the millions when it comes to licensing. And the infrastructure required to store that growing set of data can cost as much or even more than commercial licensing costs. More data means you need more CPU dedicated to analyzing it. And for a lot of customers, the added infrastructure costs can be in the tens of millions of dollars. On top of all that, you get inadequate data retention in some organizations. When your logging system is reaching its limits, right? When it's at capacity, a lot of people believe they have no choice when it comes to dropping data that they'd like to keep around. So to get the answers that you need out of your environment, you need to onboard new sources of data. There's just no way to get around that. Most companies drop large portions of high volume sources just because it's too cumbersome and costly to analyze everything. You may have retention policies in place to meet certain standards and regulations, but probably having to guess how long you can afford to keep that wider set of data around. And you may even need to revisit that data later, especially if you're investigating a security breach or trying to understand long-term trends in your IT environment. For some use cases, they may need to keep data on hand for years, and that data needs to be ready for analysis the entire time. Last thing here, systems are optimized to handle data analysis and retention separately. So what that means is you often end up using many different tools to retain and analyze all your machine data. And adding each one of these tools also adds complexity and hidden costs. So like I mentioned before, environments are getting super complex. You have your object storage, your time series databases, your data lake houses, and each of those have their own agents and their own ingestion pipelines. It really gets tough to manage it all, and it forces enterprises to make hard choices about which data to send to where. And choices usually mean trade-offs. You end up playing this three-way tug of war with cost, flexibility, and visibility. The more data you analyze and the longer you retain it, the more it's going to cost you. Standardizing on a single tool is going to limit your flexibility, right? And dropping data to keep costs down, that can limit what you learn or investigate over time. So how do you do it? How do you manage the trade-offs of analyzing everything you need to get insights from your machine data, formatted for all the tools you use without busting your budget? Well, an observability pipeline solves all of these problems. And our product, Cribl LogStream, helps teams implement an observability pipeline without replacing any existing tooling. Cribl LogStream enables customers to choose what data they want to keep, in what format, and in which data store, all while providing the assurance that they can also choose to delay any or all of those decisions with a full fidelity copy and low-cost storage. LogStream is going to provide you as a customer with a vendor agnostic solution to route data to and from any tooling source or destination. And regardless of which tool you're using, LogStream can centralize the forwarding of all that machine data, get it to the right destination, and ensure it's shaped, enriched with whatever information you need, and ready for analysis, or just on standby, right, for when it might be needed in the future. And lastly, Cribl LogStream significantly decreases an organization's logging and monitoring costs, saving customers 30% of their infrastructure costs on average, or at least that's what we're seeing from our customers. So one question that might be popping up for you is, Desi, doesn't data streaming already exist? Yes, and the data streaming solutions that do exist are not purpose-built for polystructured data. On the other hand, an observability pipeline, which again is what Cribl LogStream helps put in place, it's purpose-built to work with even the most complicated data formats. The data you need probably exists in multiple sources with different protocols that dictate how that data is generated and collected. You've likely got data coming in a variety of formats. They may not always match the formats required by the tools you use. And you've probably also come across streaming solutions that just couldn't scale with your business requirements. Cribl LogStream absolutely can. We've tested it at over 20 petabytes of data a day. So if you remember nothing else I've said today, remember this. Cribl helps implement an observability pipeline to route security and machine data where it has the most value. We help slash costs, improve performance, and get the right data where it's needed in the formats required. With Cribl LogStream, you can reshape, reduce, or route data so that you remain compliant and get the insights you need in the most cost-effective way possible. So next, I want you to see the product. My colleague, Renan Dagan from our solutions engineering team has graciously recorded a full walkthrough of some of the key uses of LogStream. Let's take a look at that now.
In this video, I am going to take you through the basic concept and demo of Cribl LogStream. The four main use cases that we see people using LogStream are the ability to route the data to the best tool. For example, LogStream is very good at taking subset of the data to, for example, Splunk, a subset of the data to Elastic, subset of the data to Amazon AWS S3, and the like. So this kind of capabilities of sending the right data to the right tool is a truly unique capabilities of LogStream. The second use case that LogStream excels at is the ability to reduce the data between the sources and the destination. For example, the ability to change logs and event to matrix, or remove all null fields because they really do not add any value, or whenever there is duplication in data, remove some of those events. So that's kind of this is a second use case that we see a lot of people using LogStream. The third one is the ability to collect data from all kind of different data sources. For example, the ability to collect data from S3, from a file system, from Office 365, and even run collectors. In other words, if, for example, you had a security incident and you want to collect the data from an object store, a data that was stored there for a year, and you just want information from last year, you can go in and schedule the job, and LogStream can go in, collect that data, and pass it to your tool of choice. Any SIM and any analytic tools can be the target. And the final set of use cases that we see people using LogStream is around enrichment and shaping of the data. For example, you can use LogStream to go in and do lookups, do enrichment as the data pass from LogStream and get manipulated. We can really, for example, take the IP and deduct from that the geo-IP or the DNS, and reverse DNS lookup are all part of the enrichment. Transforming of the data is another use case where people are using LogStream to mask the data, to encrypt the data. So it can truly change the shape of the data into something that the analytic tool can leverage. And finally, the ability to do analytics, for example, stats or sum or average are all part of the analytics, so that by the time the analytic tool on the other side sees this data, it could be transformed into a metrics. So those kind of basic use cases are covered by Cribl LogStream. From an architecture point of view, we can see two main parts to Cribl. The master node is the piece of software that really holds the configuration and management for LogStream. The actual worker bees, the piece of software that take that piece of information from Elastic Beats or from Splunk Universal Forwarder and pass it on to AWS S3, to Splunk Enterprise, to Elastic, that is called the worker node. The worker node is part of a worker group, and if you need to process 2 terabytes or you need to process 2 petabytes through Cribl LogStream, it's just a matter of adding more of these nodes to be able to accomplish the load, the volume that you want to process. From a software point of view, what I'm showing you here is the UI for the master node. The master node, once you log in, it has the capabilities of monitoring all the information that pass through LogStream, sources, destinations, and the like. The second piece of information you can see through the master node is the ability to see the health and the resources that each one of those worker nodes are currently consuming. So that is a really nice capability, because you don't have to log in to any of these worker nodes to see how well they're doing. The master node gives us the ability to see the health and actually log in directly from this UI into and drill down into these worker nodes. The third kind of tab that we highlight here is the whole notion of a worker group. A worker group is a set of configuration that mandates the different behavior for the workers themselves. For example, in this case, I have a worker group called AWS. In there, I have one worker, and I have another one called the data center one, and it's specifically for log data. And here I see that I have 2 worker nodes doing the job, doing the processing. At any given point, you can manipulate, you can configure these workers, this configuration. You can click on the configuration, do all the manipulation. Then once you're ready, once you're done with your changes, you can commit. And once you click on the commit and then deploy, the master node will take the information, put it into a Git, or if you have a remote GitHub, we can push that. And then every 10 seconds or so, the workers themselves will phone home and get the latest and greatest configuration. So as an end user, as an admin, as a developer, you do not have to deal with the workers. You just have to have this UI, the master node UI, and from the master node UI, you can do all the configuration and the manipulation. Next, I'm going to dive into the main concept that allows you to develop these data reduction, data routing, data collection, and data enrichment use cases. Routes, pipelines, sources, collectors, and destinations are the main components that allows you to develop these use cases. This diagram shows very nicely how these four interact with each other. For example, a source will collect the data and send those events to the first route. The first route then filter a subset of the data and send it to a pipeline. A pipeline then, based on functions, will enrich the data, redact the data, or mask the data and send it to a destination. And so as we go from top to bottom, we can see that each route will then filter out its own subset of the data and send it to the appropriate pipeline that will then send the information to the appropriate destination. And with that, let's go back to the master node, and let's start with destinations. In this case, this screen shows us the destinations that are currently available in this version of LogStream. For example, we can click on the Splunk destination and then just pick one of those or create a new one. And we can see quite a lot of options that you can set the Splunk as a destination. For example, there is the whole notion of a back pressure behavior. If, for example, Splunk is down, you can ask LogStream to persist the queue until Splunk is back in operation, and so on and so forth. So those kind of destinations are all available for you to add as the environment grows. You can also increase that kind of the flexibility here. Another environment that I want to highlight here is the whole notion of the capabilities. For example, if you add a destination to AWS S3, you can enable LogStream to send those events to S3 and also extract the timestamp, the source type, so that by the time the data lands in the destination, in this case S3, it will obey based on those rules and fall into the correct S3 bucket. As far as sources, we have quite a lot of enrichment as well. As we mentioned, we can collect from Kafka and Elastic Beats, as well as from syslog. And you can see that as you configure those, you tell us which port, which IP to collect from, and we will send that source into the system, as we mentioned earlier, to the routes. And the last thing I want to highlight here on the left side are the collectors. Collectors are our ability to run, for example, a schedule collection or run some sort of based on some specific dates. We can go in and ask the collector to go to S3 and collect, if you have, let's say, a security incident, collect the data from January of 2019 and just bring that data set into this historical data set into LogStream, and then pass that data into the appropriate maybe SIEM solution or analytics solution. So that's kind of where collectors are slightly different than sources, where sources will continuously run where collectors, you are in control when you want to go in and basically collect that historical data. The next thing are routes. What routes allows us to do? Routes allow us to filter the subset of the data, send those events to the appropriate pipeline, and then send that information from the pipeline to the appropriate destination. So that's kind of where route plays an integral part of LogStream. It basically combines source types, filtering, sending those to the functions, and from the function to the destination. And then we have this flag called final, which means that if this flag is turned to yes, we will not send any more of this type of data down to the follow-up routes. And so you, as a developer, can say, I want to send all of my data to S3, and then also send the Palo Alto network data to using that particular route. Of course, at any given point, you can change the order. For example, you want to have a different behavior. So that's where route really combine that kind of sources, destination, and pipeline into one unique way of executing it from the top all the way to the bottom. Next are pipelines. Pipelines are a set of functions that allows us to manipulate those events. For example, in this case, I have the Palo Alto firewall pipeline to enrich the data that came to us from a syslog. So those functions are all available as part of LogStream, and it really gives us the ability to really do the data manipulations. And the very first thing I'm going to kind of take us through is a little demonstration of data reduction in action. So for that, I'm going to go to a group on the AWS group and click on the trim JSON pipeline. The trim JSON pipeline has one function we call a parser. And as I'm showing you this demonstration, I'm going to leverage another very important concept of LogStream, and that is the ability to go in and capture data for testing. You can obviously attach subset of the data or paste your data in here, but we can truly take this particular source type and then ask LogStream to capture this data. And then we, as the people that manipulate this data, can then go in and save this as a sample file. And once we save it as a sample file, we can then go in and test our functions against this type of data set. And so, for example, in this case, I already saved a sample file called trim.bigjson.log. And on the way in, before the parser has manipulated the data, we can see what the data looks like, as well as we can see what happens once the parser has manipulated the data. We can see in orange is all the events that we changed, modified. In red, all the fields that we actually removed. and in green are the fields that we added to those events. And so as I'm looking through the details of this parser, we can tell that in this case, I asked LogStream to basically break this JSON object, extract it, manipulate it, and then reserialize it, and then put the data back into the raw events, as well as from data reduction point of view, I asked LogStream to go in, and if I see a field called multi-value headers, which we can see it right here, I asked LogStream to remove that data from the event. Also, I asked LogStream to go in, and if we see a value which is null and it does not add any actual analytic value add to the analytic tool, I also asked LogStream to remove this data set, which gives us the ability to look at the basic statistics. In other words, what these actions of removing the multi-value header and removing all null values really gives us. And in this case, we can see very clearly that we were able to reduce around 44% of the volume, which can have a significant value to analytic tools like Elastic and Splunk and the like. Also, as we are in this mode of testing our capture, we can add, let me also remove anything that starts with request context. So I type request context, just C, uppercase. I added that to fields to be removed, then save this additional capabilities. And then we can see that LogStream immediately shows you that at this point, this should not be part of the payload that we will send downstream. And also, if we click on the basic statistics, we can see that just by adding this particular field to our field to be removed, we are now can save 65% of our payload before we send this payload downstream. So that's kind of these kind of capabilities, as well as the capabilities around the capabilities of or the functions around suppressing the data. In other words, this is very similar to deduplication, can be a great value add to data reduction, sampling. Basically, give me 1 out of 10 events, 1 out of every 5 events before you send it downstream. That's another great use case for great function for data reduction use cases. Dynamic sampling, dropping events altogether. If, for example, they do not meet your requirement, you can drop those events. There's quite a lot of capabilities within the tool, within LogStream, to do data reduction. A second use case is along the lines of data enrichment. For that, I'm going to take a look at the Palo Alto firewall traffic that we saw earlier. In this case, we see several functions. For example, one function we call that the GeoIP, a function that allows us to enrich the data by looking at the Palo Alto network firewall. We can look for source IP and destination IP, and by feeding it through a lookup table, we then can match the source IP with the source geo IP, as well as the destination IP can now give us the geo IP location. So that's kind of a enrichment using the lookups, or using the ability to do DNS and reverse DNS. In other words, capture the host name for those IPs and kind of really giving us an enrichment capabilities is very much part of the capabilities of LogStream. And in this case, we also see a little bit more of a little more complex pipeline that really has some sort of indenting and grouping and the like. So that's kind of where the pipeline can really help us, as we said, add those functions and then check those functions against a capture data that we can then see the results. And the last pipeline I want to highlight is around data masking. And in this case, if we look at the capabilities of LogStream, LogStream can extract your data, your sensitive data. For example, if you have a social security number, we can mask that data. If you have a credit card, or if you have the ESN number, you can encrypt that data. And in any given point, we can go in and look at the appropriate log. In this case, the appropriate log is under sensitive data. And as we write this extraction and as we write these masking capabilities, we can see the feedback that LogStream gives us right away from taking that social security number, which is in the clear, and send that to a masked, and so that we know before we send that data downstream to your SIM solution or to your analytics solution or to your IT solution, we can definitely mask that data and give us that kind of capabilities around all of data enrichment, data reduction, and data manipulations. And to summarize what we saw so far, LogStream allows us to collect terabytes of data, manipulate the information that comes between the sources and the destinations, and with the combinations of routes, pipelines, and capture sample data, validate our assumptions. And finally, LogStream allows us to deploy all of the configurations to the workers who are going to process this end to end. With that, I just want to say thank you for listening and have a great day.
All right. So you just saw a few general use cases of Cribl LogStream. Hopefully that's got some gears turning for you around how Cribl LogStream can help you optimize your data. So let's get a little more specific. So for the past few weeks, I've been focusing in these demos on new features we've added with our latest version, LogStream 2.4. One of the things that we've added is support for Redis in the form of our Redis function. So Redis is an in-memory key value database, and Cribl LogStream's Redis function sets and gets key hash and key value combinations. Redis's in-memory caching of those key pairs enables large lookup tables that would be cumbersome with a CSV or binary lookup file, like a max-min lookup file. So next, we'll walk through how to manage large lookup tables with Redis. Here's another video from Anand to show you how that's done.
Hello, everyone. In this video, I am going to talk about how LogStream can use Redis to manage large lookup tables. Before LogStream supported Redis, the alternative was to use CSV files or the max-min GeoIP lookups. As you know, in LogStream, we have the master node, and then the master node relies on the worker nodes to do the work itself. But within the worker nodes, we have the concept called a worker process. The way we deal with lookup files is that upon a start, we will read these lookup files from disk and into each worker process memory. And for example, the MaxMind GYP lookup is approximately 60 megabytes in size, which translates to about 150 megabytes of heap size per worker process. And that with considering that each worker process by default was designed to work with 2 gigabytes of memory, which means that for very large lookup files, this kind of requirement of loading the lookup files into the worker process memory could impact LogStream available memory. So with the introduction of Redis, we have the option to use this Redis, which is an in-memory key value database. And it really enables LogStream to interact with a truly large lookup tables that could otherwise be fairly cumbersome with our CSV support or with the MaxMind lookup files. When we use Redis, we can then start considering very, very large lookup files that could be also modified on the fly. And so, for example, you could have a JSession ID table that get modified every milliseconds, and we can use that as a lookup to make sure that that LogStream it has the latest and greatest information at the time of the lookup without really the impact that otherwise will be on the worker process memory. For example, you can load in the entire Social Security numbers of the US. We have over 300 million citizens, so that could be a massive database. We can do all of those things and also make sure that Redis is up to date, and then the lookup really truly benefit from both the size processing as well as the ability for that lookup to be modified all the time. Also, another set of use cases that we can see here is that we can, within a LogStream, inside of the Redis function, we can do a set and a get, or hset, which is a hash set, and a hash get, which means that we can actually modify the Redis in-memory database from within LogStream. So this is a really nice capabilities that this integration gives us. Some website that I found very useful as you start manipulating Redis is the redis.io. Also, another website that I found very useful is around the tutorialpoint.com. There is a Redis tutorial that can give us some really nice view. For example, I wanted to set in my demo the hash set command. So by clicking on that, it gives you several examples of what exactly is needed whenever you set this command from LogStream. As far as configuring the Redis function itself within the LogStream master node, we can jump into a few examples. In here, we have a pipeline that is in charge of doing a VPC flow and enrich the IP with GeoIP. And in here, we can see that in this pipeline, we added the Redis functions. The Redis function is available as part of the list of functions that is available on LogStream. Once we added the Redis function, the very first thing we did here is we connected to that remote Redis database. After that, in order for us to pull the AWS account name from Redis, we used the get command. Get command is one of the many commands that are available in Redis, and the key that we told Redis to look for in the Redis database has the signature of account ID underscore the value in this case came from the log. The AWS account value is the one that actually populate that, and once the key has been matched in the Redis database, we populate, in this case, the AWS account name field. And so that from this step down, this kind of account name is now part of the LogStream events. And to see some additional Redis options, I have a local setup of Redis that allows me to kind of experiment with some of those set or get, or with or set up some variables, or do some of the other functionalities. So in order for me to do that, I have a local installation of Redis that I can start with using the Redis server command. And I also have the Redis client available to me so that I can, as I'm inserting information into Redis, I can actually validate some of these assumptions. So this is the Redis server and the Redis client. And again, as I mentioned earlier, I install that locally using the yum install Redis. So with that, let's take a look at the first example. In this case, I have a Redis function that I added. I added the address, the URL address of my local installation of Redis. And what I'm doing here is I'm using the Redis set command, and I am telling Redis that the key is going to be field A, and the value is going to be 1234 or test 123. And then right below that, I use the get to retrieve that same field that I said a second ago and populate a LogStream new result field with this information. Next set of commands are the commands that deal with hash. For example, the hget, the hkeys, the hgetAll, and the hset are some of those commands that Redis makes it available to us. Once we enable this section of the pipeline and save that, we can see that the hgetAll gives us both all the keys as well as the values for this particular key, actor 912, as well as the the actor keys, adjust the keys that are associated with that, as well as you can be a little bit more granular and just get one of those key and value. The one that is a little bit different is the command called hset. Hset is basically your ability to update and insert a new value. The interesting part about this command is that it actually requires 3 parameters. It requires the keys, it requires the field, and it requires the value to be inserted into Redis. In order for us to overcome this issue, we have to feed the software with an array. And in array, in this case, I have 2 values. The very first value separated by a comma, and then the second value. And we can see that requirement in the documentation, in the Redis documentation, that shows us hset is the command, this is the key, that's the field, and this is the value. And so once we have the array with these additional parameters, we can then execute the hset command and then see inside of Redis the actor 9110 with all of its parameters. So let's do get all with actor 910, and that gives us pretty much what we expected, which is in this case I just added the value of the cell phones and the social security values. The next set of commands that I was adding to LogStream is around the ability to manipulate lists. In this case, I was using the lpush and setting up a bunch of social security values into the list called SSN, as well as I'm adding a kind of the range in which I want to search in that list for the social security numbers. And once I click on save, and we can see right away that all SSNs have been was populated with a list of social security numbers. So that's the list capabilities. And with that, I'm hoping that you can leverage Redis as a way to manage your large lookups within LogStream.
Amazing. Well, now I am more than happy to take any questions that you may have about Cribl LogStream or the Redis function or Cribl in general. We have 2 pre-submitted questions, so I'm going to go ahead and answer those now. But in the meantime, if you have any questions that came up for you during this hour, please use the Q&A feature in Zoom below to submit those now. This person asked, which source protocols do you support? This is a great question, actually. So as mentioned in the demo, LogStream can receive data from various sources, including Splunk, HTTP, Elastic Beats, Kinesis, TCP/JSON, Kafka, a ton of others. And then for each source type, you can create multiple definitions depending on your requirements. So there's a ton of flexibility there. There's a lot more on this in our documentation, along with some super helpful architecture diagrams. You can see the relationship between the sources, Cribl LogStream, and the destination. So I highly recommend checking that out. It's at docs.cribl.io. This person asked, what other functions does LogStream have besides Redis? This is also a good question. So LogStream ships with several functions out of the box, and you can chain them together to meet your requirements. So if you wanted to convert JSON to CSV, for example, you can use the serialize function. The clone function is going to duplicate events in the same pipeline, and so on and so forth. Actually, in one of our other weekly demos, we do a deep dive into the GeoIP function, which allows you to enrich events with geographic fields given an IP address. So there's a lot you can do with our out-of-the-box functions, and you can add custom functions to Cribl LogStream as well. So the possibilities are endless. All right, I don't see any other questions. So that's that. After I get the recording back from this call, I'll share that with you guys via email, as well as some additional resources on what you've seen today. So those resources are going to include our documentation, which goes even more in depth on how to use LogStream with Redis and give some examples. And this isn't the only thing that we've added in 2.4, not by a long shot. So I'll send over our 2.4 blog post and our changelog, both of which detail all the new things that we've added to the tool. And then finally, I will give you the link to join our Slack community and interact with other LogStream users. We have monthly user group meetings with Cribl users and customers walking through use cases, raffles of Cribl swag, all sorts of good stuff. So it's a really great place to interact. Over the next few weeks, as you can see to the right here, we've got some great topics coming up for these weekly product demos. We will walk through a topic I'm super excited about coming up, replacing your syslog servers with LogStream. So I wanted to specifically call that one out. I will show you exactly how to do that and the volume reduction you can see as a result. We've been seeing folks get at least 30% reduction there. Also some other great topics. I mentioned the GeoIP enrichment already. And we're also doing a demo on how to pull data from Prometheus targets. So be on the lookout for those things from me, and I will see you next week. Thanks for coming.